Okay, I'm going to give this video one more try and hopefully the sound will work this time. So we've already started talking about this, so hopefully it should be pretty familiar to you, but we're going to talk about different types of voltage. Now you should already have come across and be familiar with the terms voltage and potential difference. So voltage, you know, is all about the work done per unit charge to bring it to a certain point in space because of the electric fields. And potential difference we should already have some idea of because we've talked about the idea of potential. We know that potential is measured in volts. And if I look at 2 points in space that have different potentials, the potential difference therefore is just going to be the difference between those 2 points. And it's the idea that if I move a charge from one point to another, it'll either do work or I will have to do work to make that happen. And that's where these terms come from. So just to give you the proper definition there. So for potential difference, the potential difference across a device is equal to the work done from electrical energy per unit charge passing through the device. So with potential difference, it's important to remember it's from electrical energy. Equation is going to be V equals W over Q, so V is the one we're going to use most of the time. Can be voltage, but more often it'll be potential difference. So V is volts, W is work done in joules, and Q is coulombs. Easy peasy. So just to be clear, 1 volt is the same as 1 joule per coulomb. So if you're asked to define a volt, that's what we would look for, 1 joule per coulomb. So next thing we need to talk about is electromotive force, or EMF. Now EMF is another type of voltage, so it's still about the amount of work done per unit charge, but this time the work has been doing in the opposite direction. So it's the energy that is transferred to electrical energy. So basically it's the energy we're getting from the power supply. So EMF is about the energy we put into the circuit per unit charge, and potential difference is about the energy we get out. Now unsurprisingly the equation is very similar. We're just going to use an epsilon for the EMF, and it's work done per charge. So again, EMF is in volts, energy is in joules, and charge is in coulombs. So pretty straightforward. So to be clear, the difference. Potential difference is used when the charges are losing energy by transferring that energy to another form. So for instance, on passing through a light, the electrical energy is being transferred to light energy. It is defined as the energy transferred per unit charge, so it has that definition. If we want to give a good definition, we would say which way that energy was going there. EMF is used when our charges gain energy, and it's always going to be in reference to power supply. So EMF is always going to be about power supply. And at its heart, it's exactly the same. It is also defined as the energy transferred per unit charge. So because the definitions are in essence the same, we need to make sure that we specify which direction the energy is going. Is it from electrical or to electrical? So make sure you get that firm in your head. And that is it really. So hopefully you can define potential difference, define a volt. You should definitely be able to use W equals VQ by now. Easy peasy. Voltmeter in a circuit, you should be able to do that because we did that in class. You just need to remember that the voltmeter is checking the amount of voltage at 2 different points, finding what the difference is. So it tells you how much work has been done per coulomb of charge from wherever one lead is plugged in to where the next lead is plugged in. And we should now be able to define EMF. So if you can do all that, you are well set.